Unit 5 Triangles, Preview Video 5.3, Part 2. Sit tall, close your eyes. Through your nose, deep breath. Slowly exhale. Make sure you get a parent sign off affirming that you did this video following the instructions. Okay, this page, you should be able to do this on your own. So I'd like you to pause the video, attempt to do this on your own, and then restart. Pause. Students, welcome back. As I go over this, I'll go over it quickly. If you got it correct, I expect some sort of marking, a star, a smiley like, woohoo, I got it right. If you did not get it correct, I expect to see some sort of corrections in the margin. Okay, so taking a look here. From the 50, this would be the opposite, this would be the adjacent, and our x is our hypo. Have, need, do. We have the opposite, we need the hypo, that's an OH combo, so it goes with sine. So you write out sine of theta over 1 equals opposite over hypo. That's always the order. And sine of 50 degrees over 1 equals opposite, which is 16, over hypo, which is our x. Cross multiply. You should have sine of 50 times x equals 16. You're not done yet, obviously, because x is not by itself. We are dividing by sine of 50, not 50, sine of 50. The sine ratio of 50. Okay, so at this point, now that your x is by itself, now you should have gotten your calculator. So we're doing the sine of 50, 16 divided by the sine of 50. This calculator, you need to make sure you're in degree mode, down, down, over, degrees flashing, clear. The smaller screen calculators are automatically in degree mode. So this was 16 divided by sine 50, close the parentheses up. And you get 20.886, that's going to be 20.89. On the right-hand side, it would look like this, 16 divided by 50 sine, enter. You're getting the same thing. So approximately 20.89, check for units, no units. So make a little, did you get this correct? Star smiley. Didn't get it correct? I expect a note. Now we're going to do application of Sohcahtoa, but there's some important vocabulary to understand before we do that. An angle of elevation starts at a horizontal and angles upward. That would be an angle of elevation. An angle of depression starts at a horizontal and goes downward. What is the same about elevation and depression, very importantly, is they both start at a horizontal. Angle of depression, horizontal angle downward. Angle of elevation, horizontal angle upward. Taking a look here. In the following diagram, there is one angle of elevation and one angle of depression. Sweep and label the angle of elevation and depression. So taking a close look at this, our angle of elevation here would be right here. Starts at a horizontal, angles upward. That would be our angle of elevation. Same diagram, starts at a horizontal. This person on top of the building looking downward, the looking downward angle is the angle of depression. Okay, this yellow angle is not the angle of depression because it does not start at a horizontal. It starts at a vertical. So that is not the angle of depression. Coming in this diagram, that would be your angle of elevation, horizontal going up. Horizontal going down, that would be your angle of depression. Coming here, taking a close look, this one has a little bit of a trick to it. Your angle of elevation is right here. Okay, warning, this angle is not an angle of depression because it starts at a vertical and goes outward. Sometimes you have to add the horizontal line to create an angle of either elevation or depression. In this case, you would have to draw a horizontal line angled downward. In other words, look very carefully. There is a really important characteristic. In every diagram, there's an angle of elevation and depression, even if one of them is undercover. But if you label both of them, guess what they make? Armpits of the sea. Go through this very quickly and label your angles of elevation and depression. Pause the video. Welcome back. Taking a look here. That would be your angle of elevation. I'm just going to use an E there. Angle of depression, you have to draw your horizontal going downward. That would be your angle of depression. Remember, I want you to correct your work. In this diagram, the angle of elevation, horizontal going up, and you have to draw in your horizontal going down would be your angle of depression. Once again, you can see you're creating armpits of the Z. Angle of elevation, horizontal going up. Angle of depression, horizontal going down. I'm going to take you through one problem together, one problem you're going to do on your own. You're going to be learning how to actually apply Sohcahtoa. And we're going to be following these steps. Step number 1, always finger track with your finger physically on the paper and read out loud. Okay? You're just reading. How about you try to read with me out loud? See if you can synchronize your words with mine. A research vessel uses sonar to find an unknown object on the sea floor, 1,000 feet diagonal distance from the hull of the ship. The angle of depression from the hull of the ship to the mystery object is 27 degrees. How deep, straight down, is the object from the ocean's surface? Step 2, we want to highlight or underline our key words. We have a research vessel. We have an unknown object. That object is 1,000 feet diagonal from the hull of the ship. The angle of depression from the hull to the object, 27 degrees. The question is, how deep straight down? So that's how you filter. You filter the key words, especially paying attention to the numbers. Now, this we do together. We draw a diagram, we label the diagram. Any additional information not on the diagram goes on a list. Draw, label, list, and then we cross stuff out. And then if it's Sohcahtoa, which it is, you'll be doing have, need, do. First off, we have a research vessel and we have ocean and an ocean floor. So we're going to draw all the players. Here's our ocean floor. We have water. We have a research vessel. Okay, I've done the ocean floor, object, research vessel. It says it is 1,000 feet diagonal distance to our mystery object. So here is our mysterious object. That's 1,000 feet. Notice I'm crossing stuff out as I account for it. The angle of depression from the hull of the ship to the object, so that's horizontal going down. That angle of depression is 27 degrees. We're being asked how far straight down, depth in other words, is the ship. Of course, this creates a right triangle. The minute you have a right triangle, now you're working have, need, do. Let's take a look here. We have, need, do. Let's label. This is the opposite side. This is our adjacent side, and this is our hypo. We have the hypo. It is 1,000 feet. We want the opposite, which is our x. So I have an OH combo, that is sine. Now we do circle, plug, chug. Sine of theta. I pick it up. It's 27. Our opposite is our x. Our hypo is the 1,000. When our x is by itself, which once we multiply these, x is by itself. So our x here, which is our depth, is 1,000 times sine of 27 on the calculator. So I'm going to do sine 27 times 1,000. Notice I close that parentheses, enter. Over here you have to go backwards, so 27 sine times 1,000, enter. You're getting the same thing. Notice it's 453.99 feet. So x is approximately 453.99 feet. Super important. Finger track, read out loud, highlight, underline, draw label lists, cross out, have, need, do. This page you're going to do on your own. You're going to do your basic diagram here, and then you can do your Sohcahtoa have, need, do work on this side. Really important you attempt to do this on your own first. Pause the video. Welcome back. You should have read out loud, Tom is standing 400 feet away from the tree. He uses a kilometer to measure the angle of elevation from his eye level to the top of the tree, 38. Tom is 5 feet 4 inches tall. His eye level is 5 feet above the ground. How tall is the tree? So here's our key bits of information. He's standing 400 feet away. Something called a clinometer. It measures angles. He has one next to his face. If you tilt this, this is a weight. The weight is going to line up with how much that's tilted to measure an angle of elevation. And that's called a clinometer. Angle of elevation from his eye level to the top of the tree is 38 degrees. He is physically 5 feet 4 inches tall. His eye level's 5 feet above the ground. How tall is the tree? Okay, this is how you should have labeled. Watch very carefully, one piece at a time. Tom is standing 400 feet away. So he's standing to the tree. Is 400 feet. Took care of that. From his eye level to the top of the tree, so eye level to the top of the tree, is 38 degrees. Watch carefully. In order to make this an angle of elevation, we have to draw a horizontal line, which parallels this bottom line. And this, at the horizontal line, because the angle of elevation does not start from the ground, it starts from the eye level where the clinometer is 38 degrees. Tom is 5 feet 4 inches tall, so the top of his head to the ground is 5 feet 4 inches, but at eye level, his eyes are 5 feet above the ground. The question is ultimately, how tall is the tree? How tall is the tree? Okay, so here is the trick to this. Let's see if you actually did this. If you spotted this, you're amazing. You're brilliant. If you didn't spot it, perfectly fine. You'll remember it next time. Okay, taking a very close look here. You first have to solve for this segment here that we're going to call X, which is not the ultimate segment that you want. From here to here is 400 feet. Okay, solving for that unknown. We have the adjacent side. The 400 is adjacent. We need the opposite side, which is our X. We got an OA. OA. So what do? That is going to be tangent of theta over 1 equals opposite over adjacent. That's tangent. Our theta there is 38 degrees over 1 equals opposite, which is X, over adjacent, which is 400. Cross multiply. Tan 38 times 400 equals our X. And it's not your final answer, but that is X. So tan 38 times 400. Okay, right here, we're going to go tangent 38, close the parentheses up, very important, times 400. This one, we're going to go like this, 38 tangent times 400. Okay? That's 312.51. So this is a big tree. It's already, so our x here is 312.51 feet. Now come up here. Warning, that's not the entire tree. 312.51. Because if you trace down, we are missing this little piece right here. What you're missing is the fact that you are short 5 feet because you're taking the measurement off the ground. So to get this yellow measurement all the way, you're going to have to add 5 feet. So 312.51, add 5 feet. And the total height of the tree is 317.51 feet. Highly recommend you find yourself a sibling or a parent and you attempt to explain that one last problem. It should literally take you a minute.